So number 2 is to solve the following using elimination. So you could still use the calculator, use the matrix. You're going to have a 2 by 3 matrix. Or you could use the elimination. Elimination, you're trying to eliminate a variable. So this one, looking at my x's, I have the same coefficient. So if I subtract the two equations, I'm going to eliminate x. So when I subtract, x goes away. So I have 0x. 22 minus 18 is 4y. 8 minus 0 is 8. So now I end up with 4y equals 8. So if I divide by 4, I get that y is 2. So I have y, I need to find x. So I'm going to plug it into the second equation. 6x plus 18y equals 0. And notice there's a 6, there's 18, 6 goes into 18 3 times. So that equation actually ends up being x plus 3y equals 0. So now I want to plug in y, I get x. 3 times 2 is 6 equals 0. So x is negative 6. So my answer is negative 6, 2. So number 23 asked me to write an equation of a square root function that has been vertically stretched by a factor of 3, shifted to the right 5, and shifted down 2. So by a factor that tells me I'm going to multiply. And then to the right 5 and down 2. So the first thing it told me, I'm going to multiply by 3. So I multiply the square root by 3. Second thing, to make it go to the right, I'm going to have the square root, I'm going to have x minus 2. And then the last transformation, to make it go down, I'm going to have the square root minus 2. So if I put that all together, I have y equals 3 times the square root of x minus 2 minus 2. Oops, right 5, that's minus 5. Three times the square root of x minus 5 minus 2. Number 4, write an equation of a parabola that is a vertex at negative 2, 5. There are literally a million different equations that have a parabola that has a vertex at negative 2, 5. There's actually more than a million. It's infinitely many. But the most simple equation that has a vertex at negative 2, 5 is x plus 2 squared plus 5. And you could make it have a vertical stretch or vertical compression. You make it have a reflection, all that stuff. This is the simplest form. This is the simplest parabola with a vertex at negative 2, 5. 125 over what line do inverses reflect over? Y equals x. When I'm doing the inverse, I'm switching my x and y value. So say I had a point at 2, 5. The inverse of that point would be over here at 5, 2. This is the line y equals x. So to this point, and I flipped it over the line y equals x, and it became 5, 2. On 26, it asked me to find the sum of x and z for the solution of that system. So I'm going to start by solving this system. I need to find my x, y, and z values. Then whatever I get for x and z, I'm going to add those two values together. Okay, so I need to go into the inverse, or the matrix window, second inverse, go to math, go up to B, press enter, and then I'm going to tell it to give me a 3x4 matrix. So alpha, zoom, I need a 3x4, okay, then I'm going to type in my coefficients. 3, 2, I don't have a z, so that's a 0. 13. 3, 2, 1, 13. 2, 1, 3, 9. So I have my x, my y, and my z value. So what's the sum of x and z? X plus z is 5 plus 0. That is 5. So 27 asked me to solve this absolute value equation. So I need to isolate the absolute value. So to do so, I'm going to add 6 on both sides and then divide by 3. So add 6. To give me 24, divide by 3. Five x plus 4 equals 8. So now I have the absolute value equal to a number. So remember the absolute value finds a distance from 0. So I could be on the left of 0 or on the right of 0. I don't know. So here I'm trying to find this inside of this there's some value that has a distance from 0 of 8. So I could be at the right of 0 and be at positive 8, or I could be at the left of 0 and be at negative 8. So I'm going to try both. I'm going to say the inside is equal to negative 8, and the inside is equal to positive 8. So the good thing is I'm going to do the same operation on both equations. I got to subtract 4 and then divide by 5. So I get 5x equals negative 12. 5x equals 4. So now I'm going to divide by 5 and I get x is negative 12 fifths. And this one, x is 4 fifths. Okay, 28 says list all the transformations from or of the equation. So I have the negative, I have the 1/5, I have the plus 2, and I have the plus 4. So I have 4 transformations. So the first one is the negative. The negative is a reflection. The second one, I multiplied by 2, or I'm sorry, 1/5. I don't know where I got 2 from. 1/5 is a vertical compression. The third, I added 2 on the inside. That's going to make it go left. The fourth thing, I added 4 on the outside. That makes it go up. 4. And went left 2.